So let's try and look at the following equation, which has more than one radical. We'll say that the root of x plus 1 is equal to 1 plus the root of x minus 4. Okay, and this is what I want to solve. I want to find all equations for which these two sides are equal, all values of x for which these two sides are equal. Okay, so what can I do? Well, I could move the 1 over to the left and I could square both sides. That would help me with this root x minus 4. Or I could leave things where they are and square both sides. That would help me with the x plus 1. So I have to make a choice. They're both about equivalent into how much grief they will cause me in the next step. So let's just square things as they are. If I square the left, I get x plus 1. And if I square the right, I'm going to have something a bit messier. So I'll just write this out. If you can square this in your head, that's fine. I want to make sure that everyone is following. So what I get here is I get the 1 times 1. That's nice and easy. But I'm going to get 2 of these square root of x minus 4. So I get 2 root x minus 4 plus this times this, which is just going to be x minus 4. Okay, well, one thing I can do is I can cancel that, right? I can subtract 1 from both sides. Now I have what? Well, I have x is equal to 2 root x minus 4 plus x minus 4. And I haven't been able to get rid of all the radicals. In fact, now I have a 2 here. So what can I do to make my life easier? Well, if I were to try squaring as is, it would be quite the mess if I try to square a second time. But if I can isolate this root, then maybe my life would be a little easier. So what could I do to isolate this root? Well, notice something. First of all, that x cancels out with that. And I get 4 equals 2 root x minus 4. Or 2 equals root x minus 4. And now I can square both sides. And I get 8 equals x. Now, we didn't just square both sides of the equation once. We squared both sides of the equation twice. Each time I square both sides of the equation, there is a chance that I'm creating solutions that don't really satisfy the original equation. So I really need to go and check this. So let's go back and take a look. What happens if I have 8 and I try to plug in 8? I would get, on the left, root 9, here 1, and here the root of 8 minus 4. So is it true that radical 9 is 1 plus radical 4? Sure, because 3 is 1 plus 2. So this is my solution to this problem.